Good morning everyone and welcome to today's webinar. My name is Kira Proctor and I'm the Managing Director of the A. Proctor Group, and today we're looking at how the principles of passive house design translate into the context of large buildings. Designing high-rise apartments, offices, schools and hospitals which utilise passive design strategies presents a range of challenges and opportunities. But with advances in materials, experience and site practice increasing all the time, the balance is more favourable to the implementation of passive strategies than it's ever been. We'll start today with a brief refresher on the core principles of passive house design before exploring how these can be scaled up to suit high-rise buildings or large-scale developments. Our focus will shift from individual one-off projects to broader applications that demonstrate how passive house standards can drive energy efficiency and sustainability across entire communities. The Passive House standard was developed and formalised in the 1990s by a group of researchers in the German city of Darmstadt who were looking at ways to reduce dependence on fossil fuels and nuclear power to heat homes. The basic principles of passive homes date back a lot further than this though, with examples of buildings using these techniques dating back many centuries found all over the world. The Passive House Institute sought to codify these techniques into a framework for constructing homes that required minimal energy use for both heating and cooling and delivered significantly improved indoor environmental conditions. Whilst this framework has increased in scope and more knowledge, along with a greater range of products and systems now included, the basics have changed very little over the past 35 years. The main characteristics of a Passive House standard building are super insulation. This requires very high levels of thermal insulation across the whole building envelope. While the difference in insulation levels between passive house building and a typical new build is a lot less than it once was, it's still a very important aspect of controlling and managing both heat losses and heat gains. Thermal bridge-free design. As levels in insulation in the heated envelope increase, it becomes increasingly important to ensure the insulation is as continuous as possible. If the insulation layer is broken, for example, at window reveals or structural members, this not only increases heat loss but can lead to cold spots and mould growth. Design and detailing to avoid these thermal bridges is far simpler if they're identified and addressed at an early stage, and modern insulation materials such as Spacetherm Aerogel can simplify this further, with relatively little additional thickness required to deliver a significant impact on thermal bridging. Ensuring the continuity of the high-performance thermal envelope extends to the windows and doors. The opening in a building needs to be carefully designed and oriented to help manage solar gains as well as heat losses. They also require thermally broken frames and reveals to minimise the cold bridging in these areas. Even seemingly minor changes in orientation and shading conditions can have a significant impact on the annual energy use. Probably the best known of the passive principles is building as airtight as possible, with the pressure test result of less than 0.6 air changes per hour required to meet the standard. While this ACH value isn't directly comparable to the values used by the building regulations in the UK, it represents a considerably lower level of air leakage. This is also verified using a blower door test, as it's not only critical to minimise heat loss due to air movement, but it's important in ensuring the correct function and optimisation of building systems. Again, detailing and correct product choice can make this a lot easier now than it would have been in the past. Membranes like our wrap-tight self-adhesive vapor-permeable membrane can make ensuring a low level of unplanned air movement considerably more straightforward. It's important to remember that when we talk about airtight buildings, this only refers to unplanned air movement. Ensuring a good supply of fresh air into the habitable spaces is a critical part of the passive house design philosophy. Because introducing outdoor air can contribute to cooling down the building, modern passive buildings use mechanical ventilation systems with heat recovery. These systems use outgoing warm air to preheat the incoming fresh air, ensuring the heat loss is minimised. Well-designed and constructed airtight building fabric is an important part of ensuring these systems work as effectively as possible, as any air drawn into the building without going through the heat recovery system will lead to unaccounted heat loss. Reducing the energy required to heat and cool the building is the end point of the principles of Passive House, with the principle being to keep energy inputs for heating and cooling below 15 kilowatt hours per square metre of floor area per year, and the primary energy demand below 60 kilowatt hours per metre squared per year. There's some additional details around climate variations, but the basic principle is to keep the energy requirements relatively constant and vary the required fabric insulation across climate zones. Regardless of its function, any large building is an extremely complex system made up of a huge range of subsystems dealing with heating, cooling, ventilation, lighting, and networking. Added to this is the range of systems associated with its function. This presents a huge challenge to designers, but also presents a wide range of opportunities to optimize the building fabric and systems to match the requirements present. When considering a passive approach, fully understanding how these systems interact and the precise levels of performance required is the key to delivering the performance. Internal heat gains from occupants, lighting, and equipment can significantly offset heating demand, which is great in winter but potentially problematic in summer if it leads to overheating. Usage diversity means we can't rely on a one-size-fits-all approach. Each building must be the product of its unique function, layout, and location. If we consider how a school is used compared to an office or leisure centre, we can see significant differences. A building in continuous use like a hospital will not only be fairly predictable in terms of energy and occupancy, but will require a constant and consistent temperature and humidity to be maintained throughout. On the other hand, it may have more complex air quality and filtration requirements than a school. In a school, there will be periods of extremely high occupancy, but also periods where the building will be empty. This introduces large shifts in the heat generated by the occupants. An office building would lie somewhere in between in terms of occupancy patterns, but depending on the business may have a large amount of heating generating computers and servers throughout the building, some of which may require additional cooling or ventilation to ensure efficient operation. Finally, a project like a swimming pool and leisure centre will have a huge range of environmental requirements to maintain swimming pool areas, gyms and staff offices at often quite different temperatures to ensure occupant comfort is maintained. To account for all of these requirements, a system of zoning is required to manage controls and environmental conditions, and this must also account for variations in occupancy and usage patterns over time. In our leisure centre example, illustrated well by the recently completed St Sidwell's Point in Exeter, the pool area, which requires a lot of heat input, is situated on a south-facing elevation, with lots of glazing to maximise solar gain, which the gym and dry side activity spaces are on the inherently cooler north side. Heat pumps are also used to transfer heat generated in this space to the pool area, again reducing the requirement to input further heat beyond that generated by the occupants. Plant rooms and systems are also decentralised and distributed throughout the building, minimising efficiency losses associated with long duct runs, and allowing each set of systems to be optimised specifically for the areas they service. Similarly, the environment of the pool area is kept at a specific temperature and humidity to reduce evaporative losses from the pool itself, and the pool water can also be used as a fabric heat store. This approach shows the tightly integrated nature of passive design, which ideally must be integrated right from the beginning to ensure the performance of the building and systems matches its function. Each of these measures we've discussed for St Sidwell's Point works in the specific case, but may not be transferable or universal. A decentralised heating and ventilation system, for example, may be overall less efficient than a single large unit in a different application, or might have more complex maintenance requirements that offset the overall benefit. It's also important to avoid the temptation to oversize systems in HVAC capacity, just in case, as this will result in inefficient operation and might necessitate design compromises elsewhere. The building envelope itself has a big impact on the energy performance, and ensuring the building fabric is well designed and optimised is the cornerstone of the fabric-first approach to energy performance. This means ensuring the passive fabric of the building, the fundamental insulation and air leakage control strategies are in place before considering the use of active mechanical systems. A good way to think of this is like filling a bucket with water. If the bucket has holes in it, then it will always take more input to fill it than is optimal. So, even if our energy input comes from 100% renewable energy, which in the case of large building could mean a substantial photovoltaic array or on-site wind generation, losing lots of the heating and cooling to poorly insulated fabric is not exactly a sound approach. In a large facade system, there are two principal functions we need to design for. Firstly, to prevent heat loss to the outside, and secondly, to limit heat gain from the sun. Achieving these objectives requires the facade to be both well designed and well aligned with respect to the movement of the sun. As well as considering the purpose of the spaces and whether they require mainly cooling or heating, it's also necessary to consider overshading, whether by adding architectural elements to the facade itself or by using adjacent parts of the building or other structures to provide shading. If designed and accounted for properly, this can have a significant impact on the energy requirement if the solar gains can either be harnessed or reduced depending on the requirements of each individual space. To ensure the design is optimised to work with these energy inputs, it's important to ensure the performance of the non-glazed portions of the facade are also maximised. To achieve this, we need to consider three critical factors: the thermal insulation itself, thermal bridging and air leakage. It goes without saying that buildings designed to Passive House standards require high levels of thermal insulation. This has always been the case, and in fact mainstream building regulations are only now catching up to the standard Passive House has required since its introduction. A typical Passive House building envelope will have a U value for opaque elements of between 0.1 and 0.15 watts per metre squared Kelvin, which requires a substantial thickness of insulation. At this level, it becomes increasingly impractical to increase the thickness of insulation much further, as U values become harder to reduce the lower they get. This diminishing return also means the brackets, flashings and other components in the facade become too large. This practical maximum level of insulation means the effects of both thermal bridging and air leakage become increasingly important, and the passive standard places a large emphasis on reducing both as far as possible. Thermal bridging occurs in two ways in a facade system. The first, repeating bridges, occur at studs and infill panels and structural frames, and these are typically accounted for in our U-value calculations. The second, non-repeating, occurs at openings and junctions. Ensuring a continuous layer of thermal insulation is present across any elements and areas where the primary insulation is reduced, removed or otherwise compromised is of utmost importance, but can also prove problematic. In the early days of passive construction, this could result in design compromises to minimise these problems, such as simple block-like repeating forms and thick frames around openings. Today though, higher performing insulation materials such as our Spacetherm aerogel can help reduce these compromises. Spacetherm allows a meaningful level of thermal insulation to be fitted into even extremely small spaces, such as around studs and columns and at openings and window reveals. This system is available with a range of laminate facings from magnesium oxide board to the wrapped-out self-adhesive air barrier to suit almost any application. The wrapped-out air barrier membrane, with or without a Spacetherm backing, can play an important role in managing the third of our considerations, air leakage. This affects the energy use directly by allowing warm air to escape the heated spaces to outside, called exfiltration, and also by allowing cold external air to enter the habitable zone, called infiltration. It can also have an indirect effect via the complicated heating and ventilation systems used in larger buildings. Even without the heat recovery systems required by Passive House, these complex HVAC systems rely on clear and well-defined design criteria to function efficiently, which include air leakage rates. A system designed to work at a given pressure will not work correctly, as large and unknown amounts of air can pass through the fabric of the facade and so may require higher than anticipated levels of energy input to deliver the required air changes. Heat recovery systems will make this even more critical, as cold air leaking into the heated spaces will seriously inhibit the ability of the heat recovery system to maintain the designed internal temperature. Likewise, if our system relies on the transfer of heat from warm spaces to cooler spaces, such as at St Sidwell's Point, more energy input will be required to compensate for this loss. So, as part of the overall high-efficiency approach, low levels of unplanned air movement are another of the defining characteristics of Passive House standard buildings. As insulation levels increase, the effect these additional energy losses can have on an overall energy requirement becomes increasingly significant. Products like Wrapped-Out can assist with this, as they make it far easier to achieve the exceptionally low air leakage rates required, which in turn allows for more reliable optimization of systems. It can do this because the vapor permeable and self-adhesive nature of the material allows it to be positioned wherever in the construction, makes the installation of a continuous airtight layer most straightforward. A traditional vapor-tight air and vapor control layer used internally requires a lot of penetrations to be sealed, a process that can be avoided by moving the air barrier to the outside of the structure. This positioning can also allow pressure testing to be conducted earlier in the build programme, before the installation of internal services. This in turn means that problems can be rectified more easily, whilst access to the air barrier layer is comparatively unimpeded. The membrane can also be used to provide an effective airtight line on all types of structures. An important consideration for larger buildings is how the structure itself affects the energy use and life cycle assessments. Extensive use of concrete, as is typical of larger scale buildings, in the UK at least, may not seem the greenest solution compared to something like cross-laminated timber. But, as with many of the factors we've discussed, this can depend on the specific of the structure and its purpose. The thermal mass in concrete frames can be utilised as a very effective heat store, helping to regulate temperature fluctuations. Lower nighttime temperatures can be used to cool thermal mass, for example in an office, helping to reduce daytime cooling system loads. A concrete frame can also function better acoustically, where the mass of the slabs will reduce noise transmission between floors. As well as indoor air quality, good acoustics can be an important consideration, particularly in projects like schools or performance spaces. On the other hand, a more industrialised approach using cross-laminated timber frames or structural insulated panels can often more easily deliver high thermal insulation and airtightness performance, can be erected quickly with less work required on site, and reduce potential for weather delays. So once again, the key factor is to ensure the building fabric and use any additional considerations such as embodied carbon and energy are fully understood and properly integrated into the design process. The early involvement of suitable design and delivery partners can go a long way to ensuring this process runs smoothly, beginning with the involvement of the Passive House design consultants from an early stage. Managing the cross-disciplinary interactions of the many systems and components involved and ensuring they all contribute optimally to meeting the requirements of the Passive House standard requires knowledge and experience. Establishing good communication and knowledge transfer throughout the project team from designers to installers is the key foundation, without which the necessary quality of design and workmanship is unlikely to be achieved first time. The complexities of large buildings and the large number of design principles and trades involved introduces substantial technical risk throughout the process which must be managed. In this context, product and system suppliers and manufacturers often provide the common thread, communicating with all parties throughout the process. This begins at the design stages, where the complex modelling of energy performance and condensation risk require accurate test information for physical properties, and ideally also product certification to ensure fitness for purpose and consistent quality. From our work with designers and passive consultants on a range of projects of all sizes, we at the A Proctor Group have gained knowledge and experience of what information is required and when. Once the project is on site, this experience extends to working with contractors via our toolbox talks and site inspections. Achieving buy-in from all parties streamlines the process considerably, and robust systems to ensure training and upskilling takes place goes a long way to meeting this. As manufacturers, we can help ensure the detailing of facade systems is as simple as possible to construct and help ensure the installers understand the reasoning behind each detail. This, of course, also makes ensuring the correct products and systems are specified and installed as intended critically important. Achieving the quality installations necessary to deliver a high-performance thermal envelope requires rigorous Q&A throughout the process, with training and practice on mock-ups a useful tool. The wrap-tight system also makes compartmentalising the airtight envelope simpler, facilitating staged air leakage testing early in the process, with less likelihood of extensive remediation. This reduces the pressure to meet tough performance criteria first time across a huge structure, assisting the development of the necessary skills. Another important consideration here is fostering a no-fault culture, where the focus is on ensuring a quality high-end result rather than establishing blame. Faults and errors that can be simply resolved should not be covered up or bodged around, as this can lead to a significantly trickier remediation process later in the build. Bringing all these factors together, we can see that applying passive principles to large projects is primarily a matter of considering the relationship between the fabric of the building and its function. Achieving the degree of integration required across all disciplines involved in the design and construction process demands that all parties adopt a more collaborative mindset, with communications between all parties involved placed at the forefront. A payoff for this, however, is not just a high quality and efficient building, which is perfectly suited to its purpose, but also establishing a greater understanding of the problems faced by all parties involved in the design and build process. In turn, this leads to the development of innovative approaches and solutions, and in many ways the application of Passive House principles to large projects is more straightforward than smaller jobs, where simple off-the-shelf solutions are more likely to already exist. By developing relationships from design to construction to end use, and recognising the inherent value of a high-quality building envelope, large-scale passive buildings can provide a catalyst to drive progress and demonstrate the benefits of low-energy design. We'll now move to discuss this further in the Q&A session. Good morning, everyone. I hope you're having a great Friday today. Thank you very much for attending today. we now go on to our Q&A. So just a couple of housekeeping things before we go. This is our third webinar of the year. Very quick date for your diary. The 31st of October, so Halloween, we will be doing another Proctor webinar on aerogels and space therm. So that's 10 a.m. the usual time on the 31st of October. We now have almost 250,000 views of our webinars, so we're really excited to keep these going and bringing relevant and interesting content to you. That's the reason why we're not doing them quite so frequently, just because we're always working on these in between. So I'm sorry they're not monthly, but we want to make sure they are relevant and interesting. So that's why they're a bit more distanced. As you know, we try our best to answer all of your questions, so please either ask them here on the YouTube feed, email us webinar@proctorgroup.com, and I've already got a few good ones in from before the webinar, or you can DM us on social media at Proctor Group. If you want to request a product sample pack, contain the materials discussed on this webinar, book a meeting, chat in further detail about a specific project, you can do that on our webinar page. And personalised CPD certification is also available at the same link. If you've registered, you'll receive a follow-up email, with all the links and a link to the replay. So feel free to pass that around colleagues if you find it beneficial. And registration is still open for this week's webinar if you would like to get that replay link. It does really help us if you enjoyed the webinar to give us a thumbs up, and if you subscribe to our channel, you'll be kept informed of anything that we have coming in the pipeline. So in between our webinars, we do quite a lot of informative videos and install guides and lots of different things. So please subscribe and you'll be kept up to date. So this week we have some familiar faces. We have our Head of Business Development and Global Sales, Adam Salt. Morning, Adam.
Morning, everyone.
Morning. Our Senior Technical Advisor, Pamela Howitt.
Morning, everyone.
Morning, Pam. And a new face, not to the business, but to the webinar today, Matthew Owen, who's our Business Development Manager for high-rise and facades in the southeast of England.
Morning, Kira. Morning, everyone.
Morning. Okay, so I'm going to jump right onto the questions because I'm conscious of time and there's quite a few coming through on the feed already. So just bear with me because these are coming in through different channels. But if I miss any, we will follow up by email or feel free to remind me on the YouTube feed, but we'll try and get to them all. And we tend to stay as long as needed to answer them. So if you need to drop off, then that's no problem at all. You can catch up at a later date. So if I can start with Marina Phillips, who's asked, are there any specific, hold on a second, I've lost it here. Any specific challenges in delivering a Passive House project? So Matthew, seeing as you're our new face, can I start with you, please?
Yeah, it's a really good question. So obviously I go to a lot of architects' practices, and what I would say is it can be quite daunting, certainly for anyone that hasn't delivered a Passive House project. Or potentially looking at delivering a passive house project. I would say working early stages, design stages, certainly with manufacturers, similar to ourselves for obviously membranes, but obviously the other areas where you've got your ventilation, working with them at early stages, because also they can help as well. And I didn't realize to what extent other people can actually help, certainly from a design aspect side of things as well. So I would say once you've done a few passive house projects, I would say you're well away. But one thing I have also noticed as well is within certain practices, you sometimes will find that they will have a designated passive house certified designer, which is also great because then they've got someone to use to help support and get over that line with that project. So yeah, that's.
Thank you, Matthew. Much appreciated. Pam, Greg Robertson said, what role does thermal modelling play during the design phase of projects?
Sorry, you can tell I've not done one of these for a while. I forgot to unmute myself there. Sorry, yes, that's a great.
It is a Friday.
It's a great question again. So thermal modelling, historically, when you sort of did your whole house modelling energy assessment, taking into account either be it SAP or SBEM or even the PHPP planning, passive house planning package, you can put in thermal bridging. So as the webinar video had, that's your sort of your non-repeating. So that's things like the window reveals, openings, etc. You could put in a default worst case scenario situation, And I think you can still do that. However, in this day and age where we're looking at much more energy efficient, higher insulative, potentially, sort of like trying to cut down on those aspects, it's really, really important to accurately model them, because by going with defaults, you can actually have a huge hit on your overall performance and really not accurately look at how that building works. So by doing that, you're making sure that you've not got spots where, for example, steel lintels are going to be an issue with condensation, which could then lead to mold in those areas. You're making sure that you can optimize and work everything together. Again, that feeds into things like internal comfort, all aspects of that design. So it is really, really important to start looking at that for each of them and not just go with default designs now. I think that's really, it's okay for probably low level, but certainly not for high spec, large passive house structures. Just doesn't work any longer.
Okay, thanks, Pam. If I can stick with you on the next one, please, as well. James has asked, how do Procter Group's products such as WrapTight, ProCheck, ProBreathe specifically support the delivery of passive house standards?
Okay, so we develop a lot of products in our core range to aid achieving passive house, mainly by looking at the air leakage. So I know that when or passive houses designs were really just coming into the fore in the UK, there was a lot of emphasis on your internal detailing of the vapor control layer. So it was, sort of, I remember going to Passive House conference and there was like a college building being built, and the guy had an image of this massive room that was just all membranes, tapes. The guys would go around with about 3 or 4 different tapes on their belts to go and fix everything. And it was a terribly, terribly complicated and time consuming and therefore costly way of achieving airtightness. So when we developed WrapTight and looked at ways of using it lent itself very well to sort of taking that airtightness line external. So once you've got your insulation, your cladding on, it's not going to be disturbed by oncoming trades, which can be the case with a vapor control layer. Now, we're not saying a vapor control layer should be dropped out of it, because it's really important to look at the moisture management and the way that building works and that wall works. But what it does is it takes the onus of one element for doing that airtightness. So a combination of things like our ProCheck range, which can be everything adaptive, our ProCheck Adapt intelligent membrane, which is great for wood fibre natural materials, right up to our fire resistant ones like FR200 and ProCheck A2. They can be used alongside WrapTight and ProBreathe externally to give you a very vapor and moisture balanced wall, as well as a wall that provides very good high levels of air tightness, which is critical for passive house and low energy buildings.
Okay, thanks, Pam. That kind of leads on to a question I'm going to ask you, Adam, from the chat from Mel Farage. So Pam explained about some of the placement there of the materials. But what Mel's actually asking, so she said it's really relevant. It's easy to understand traditional vapor barriers and how they're applied on the interface of the walls, as Pam's just described. But can you actually explain the fundamentals of how WrapTight works when it's applied to the outer face? So we're going into how the product functions itself and how that works.
Yeah, I was actually going to add to that as well with a case study we worked on with Kenton Jones doing a modular system with a project up in Anglesey. You should be able to find it on our website, but we can send it out after. What was quite interesting about that project was the first house design they did was with an external taped on breather membrane and an internal taped on vapor control layer, and they struggled to achieve the air tightness even in a controlled environment like a modular factory. And I remember for the second house, I got the phone call and said, could we look at WrapTight and put that externally? And they achieved the air tightness target, which was, I think, close to passive house standard first time. I think they achieved less than 1. So I like that because the two buildings are side by side, exactly the same design, other than the membrane. And the difference is on paper they're pretty much the same. They can achieve air tightness as close to zero, kind of as humanly possible, but it's the way they're applied and the way they're installed on site and the simplicity Raptite offers by being a self-adhesive product, peel and stick on the outside, away from all those internal penetrations. The penetrations externally are much bigger. They're normally more compressed back to the system. They're installed by the same contractors. So internally, the penetrations are done by different contractors, whether it's an electrician or plumber. Do they care about the internal works? Maybe not. Trying to get the job done as quickly as possible. And then the biggest benefit to Raptite in these designs for me is the longevity of your building with your air tightness. So internally, I can now penetrate my vapor control layer by putting a picture up or moving a plug socket. I can't penetrate my external one without doing a whole redesign of my building, and getting full contractor work in. So my air tightness is likely to be the same 5, 10, 15 years in the future.
Yeah. And the other thing I would say there to Mel is if it's worthwhile, maybe someone from Procter could post in the chat about, one of the webinars or detail information we've done about the difference between different membranes. So of course, the uniqueness of Raptite in terms of it being a breathable vapor permeable membrane and it with an airtight film in the center, meaning it's an airtight membrane and being self-adhered makes it quite different to the other breathers that are out there externally. And so as Adam's been describing, it's much easier to achieve that airtight line externally than internally. But fundamentally, there's some differences in the actual product, which is worthwhile having a look at if you're looking at utilising it in your projects.
And the vapor permeability is the uniqueness with Raptite, because you can achieving vapor permeability with an adhesive is the difficult part. It kind of blocks that vapor permeability, and that's the uniqueness we have with Raptite, is we can facilitate it without the need for a primer. Additional primers can cause another blockage to that vapor permeability. So that's why it's a unique system out there in the market.
Great point. Matt, Josh has asked, how feasible is it to implement Passive House principles in large-scale residential or commercial developments?
Really good question. So I recently attended an event with a shall we say, passive house consultancy company. And what was really great about it was they were looking at different sort of sizes of buildings, from high rise to mid rise to houses to also retrofit. And what they did is they actually done a cost analysis and done a sort of like a breakdown versus certainly on high rise. And I was actually quite shocked with the number that actually came up. It was a very low percentage. They didn't go down and break really down into cost, but it was such a small percentage of cost versus how we would normally construct it. So I found that very insightful and also helpful for me, because as probably a lot of us would know internally, I've been working on a couple of things internally, looking at obviously costs, sort of cost comparisons of Raptite versus traditional methods. And that sort of hit homes what I'm actually also, looking at with sort of customers, clients and contractors. The other thing that I'm also seeing as well, certainly in London and the Southeast, is a lot of housing associations, councils, main contractors, they're now announcing, certainly this year as well, about, that they're going to do sort of low energy, passive house, high rise buildings in and around London. We've certainly got a nice little pocket just outside of London, a place called Oxford, that seems to be a nice example of where they're doing a lot of energy efficient buildings. Funny enough, I was there on Tuesday on one of our projects as well. So I think more people that get on board with it, because obviously low energy is really important and sustainability. I'm seeing a lot of people, and there was one main contractor that I was speaking to. He was one of the passive house certified designers for that company. And I said, just out of curiosity, I said, how many new builds, what percentage is passive house? And he said 40%. And I was like, wow, I wasn't expecting that such a high number. So implementing it, I think, like I was saying earlier, if you work with manufacturers at early stages, and we get the designs right, And we support the practices as well that are also designing it through, obviously, Proctors do a CPD on Passive House, looking at the 5 different principles. We can certainly help and guide them, but really home in on certainly the airtightness side of things, where we would come into it, like Adam was saying about the wrap tight, etc.
Yeah. There's some great examples of case studies on our website where we've done an awful lot of the Passive House schools in Scotland as well, because obviously Scotland's pushing that a little bit further in performance at the moment. And they're fantastic. And the air test results, I just had one back last week from a main contractor who just emailed to say, wow, I can't believe that we've achieved this first time kind of thing. So worth having a look at those case studies too. Right, I'll stick to asking the questions. So Colin Christie has asked, and I'll come back to Lucy, so bear with me, Lucy. Colin Christie has asked Pam, is it safe to assume local building control departments can police Passive House standards prior to certifying their completion approval?
Yes, so one of the benefits about Passive House is obviously you have to design it with the products, etc. in place. So it then makes it very difficult to substitute products into it. But building control officers will still have to sign it off from the point of view of ensuring the compliance with building regulations. It is then the case of should you wish to go down the route of having your Passive House certified building final certification, that then would be done by a Passive House designer. And I know that you yourself, Kira, opted not to go down that route with your property, and we did the webinar on it before. So although it was designed as Passive House, you didn't go as far as the last step. So building control officers still do have that duty of care and assessment of the compliance to building regulations. And in fact, in Scotland, as you touched on, Kira, we're starting to move towards looking to incorporate that as a standardised element to the building regulations for new builds. So it'll be interesting to see exactly how that pans out. They're doing a lot of work on seeing how that integrates, but the way they're working at the moment, it looks like it's going to be a lot easier to gain compliance across several different formats. So it should streamline the process.
Yeah, thanks, Steph. Right, I'll come back to Lucy. Sorry, I skipped over that one. Adam, what are the implications for construction materials and methods when building Passive House at large scale?
I suppose it's with all projects, planning becomes quite key with a lot of the construction materials. I think some of the challenges is looking at the design work on paper and actually installing it is always 2 different things. Now, I was lucky enough to work on St Sidwell's Point in Exeter, and we got to site sometimes and we were looking at the details, and then when you're actually on site, it was like, well, actually that doesn't quite work the same way, and we had to kind of almost do some redesigns or kind of think of different solutions on site, which makes it a bit more challenging. So really kind of what we've been talking about recently is getting a bit more designer experience on site, inviting sort of architects to get them involved on site to actually see some of their drawings and designs. I actually think Matthew was telling me recently, a lot of the architects and the practices he's going to aren't going to site and actually experiencing a lot of these projects and details. And it's that what's on paper is completely different to actually what's on site. So I think that's one of the biggest challenges. And then communication resolves that really. If subcontractors and facade contractors and main contractors are all involved with the architects early on, as well as all the manufacturers and suppliers, that helps overcoming a lot of those challenges, really.
Absolutely. Charles Harrison has asked, would the use of external vapor control barriers increase the risk of interstitial condensation, and what methods are available for mitigating this? So Pam, I'll maybe come back to you on this one, or maybe Adam, whoever's like, maybe it's good to clarify just what we're talking about with the external side and answering the question as well. So one of you want to jump in?
You go first, Pam.
I was going to say he was going to go.
Or Matthew, I mean, whoever.
I'll follow on.
Yeah. So yes, so it's important to understand the sort of the differences. So an external vapor control barrier will not allow vapor to pass through. A permeable product will. BS 5250 will set down the parameters of what those should be. What we're saying is there is the potential that you could use a vapor control layer on the outside of your sheathing board if your SFS stud, for example, doesn't have insulation in it, and all your insulation is going external to the frame, assuming we're talking about SFS frames and infill. That's okay because you've got your vapor control layer on the warm side. If you want to minimize the build up on the outside of your structural line and add insulation within the SFS stud or internally, by placing a vapor control layer in the middle of that, you might inhibit and stop the movement of vapor through that wall. So it's very much looking at, again, going back to our ham principles, which is balancing that heat, air, and moisture movement through that wall. And I think really you have to look at it from, we use the word holistic quite a lot, but it is true. You need to know what insulations are being used, why, where, what the type of building is to be able to look at saying, well, do you know what? You've got the majority of your insulation externally, vapor control layer is okay, just don't put any more insulation in your stud. But what happens if in a few years' time people don't necessarily know what's there? Now, I get it, new builds have got like manuals, etc., that should be noting down all these elements that are being used. But what happens if somebody decides, oh, do you know what, I'm going to open up my wall and put some more insulation in there? You could then suddenly start creating a problem. So by using vapor permeables to provide that airtightness line, it can make your building more robust and less likely to have problems. Also look at the weathering aspect. This is probably something that we don't think about a lot. Large scale, low energy, passive house type buildings take a long time to go up. A lot of vapor control layers are not designed to be exposed long term to UV and weathering, and may not be robust enough to be used in an external application. So by doing that, you may actually be compromising your membrane before you even get your external cladding on. So again, it's a very careful balancing act of what's right for the building, what's right for the construction phase, and what's right for the long-term life of that building as well.
Yeah, I think sometimes the terminology gets a bit confusing in the industry.
Yeah.
When we talk about air tightness, it's always gone hand in hand with vapor tightness. So anyone says I need an airtight material, they think of a vapor tight vapor control layer. We're not talking about that with wrap tight. Wrap tight is vapor permeable, so it's not a vapor control layer. It can be positioned anywhere in the construction because it's moisture neutral, but it is airtight. So I think the best analogy we have to kind of explain that is a football goal. You kick a football into the net, the ball won't pass through. But if we use the tennis ball, the ball would pass through. So we're playing with the molecule shapes and sizes through the membrane, through the adhesive to facilitate the vapor permeability, but not the air passing through.
Well explained, Adam.
And one other thing, actually, just talking about climates, we have a lot of projects around the world. And if we're in, say, the Middle East, we might then look at a different route where the vapor control layer is positioned on the outside because the external is a lot hotter than the internal, where it's got reverse vapor drive. So that's another exception to the rule.
Very good. Right, a couple more great questions on the feed. I'm just going to do one that we've had in via email from Danielle. Matt, seeing as this is based in London, I'm going to ask you, can you share examples and insights to some larger scale passive house projects you've been exposed to within the London southeast of England?
Yes, I would love to. So we've got several live projects that are actually up to Passive House standard at the moment. One thing that we want to do is work at really early stages. You know, as soon as they turn up on site, we want to make sure that obviously we're doing toolbox talks, we're on site, and we're also talking to the installation teams in regarding to making sure that the membrane is being stored and to what standard. Certainly, obviously, as per installation guides. One of the other things that I've also been noticing as well is when the building starts to go up, what they're trying to do is try and finish a couple of dwellings get everything all done, everything on, membranes, the lot, get it all fully done, and then do airtight tests really, really early on site, just to make sure that they know that they're getting their air tightness line from those first few dwellings before then they start then repeating and then obviously going up higher and higher and higher. Obviously, the other thing as well, on when I'm on site, they're like, oh, I'm so used to a taped membrane or stapling it on the wall. What's this stuff that it just sticks everywhere, you know? And it's obviously being wrapped tight, it's fully self-adhered, it's obviously Passive House certified. So sometimes they might not have been exposed, that they've been exposed to membranes, but not a self-adhered membrane. So we obviously just guide them to make sure that obviously the install is correct, the overlaps are correct, etc., etc. And also one other thing I have noticed as well is on certain Passive House, depending on what the substrate makeup is that sometimes the insulation on the outside of the building doesn't have to be that crazy. And what I mean by that is, if you've got a really good air tightness line, you can offset that with your dwellings emissions rate. So you don't need massive thicknesses of insulation. Not necessarily if you're getting your sort of air tightness down. So you can offset that with the insulation. And then obviously for anyone, you know, we've obviously recently done a video at one of our Passive House projects, which is on our website. If anyone looks under Wraptight, they can see me working with the brickwork contractor, and the brickwork contractor was installing our membranes. It's not difficult. You know, they're used to laying bricks, you know, but they're installing our membranes. So, and I've found it very insightful talking to the bricklayer and how they do it, how they overcome, not just get it up really quick and charge per square meter to get it up quick. They've been giving them day rates to sort of make sure that that meticulous sort of detail has been, you know, so they don't have to revisit because they've been obviously putting it up too quick. So yeah, so there's lots of insights that I can share and could share, but I mean, obviously, if anyone wants to pick my brains at any CPD events, they're more than welcome to. But yeah,
just
thanks for the question.
Good. Right, some really good technical questions. I'm going to come back to Mel, which kind of ties in with what we were just talking about in the prior question. So she's saying without an internal vapor barrier, you'd allow for vapor to penetrate an external wall, leading to internal condensation in the wall in cold weather. So does Wraptight work on its own? So perhaps, Adam, could you clarify our position with Wraptight being used with a vapor barrier, if it's needed, when it's needed, etc., please?
Yeah, I'll give it a go and then Pam can fill in the blanks. But no, I think I'm going to use Ian, our technical director's favorite phrase here. It depends. It's an optional kind of thing to the design, and it's going to depend on every part of the construction, what materials are used, where the position of the insulation is, what types of the insulation are, and how that construction is during the construction phase as well. But you can run calculations without that internal vapor control layer and still find it's not adding anything to the design, and therefore we can remove it. It is also still good practice to include one as well. So it's not a straightforward answer. It depends, but we can analyze the designs and weigh up whether it's needed or not. And it's more, what we're more talking about at Wraptight is how we're achieving that air tightness, and the moving that focus from the air tightness aspect internally to externally, but the vapor tightness might still be required internally. That's a whole nother debate and topic, depending on the design.
Yeah, as you said in your last answer, there's often confusion, isn't there, between the vapor barrier and the air barrier, and I think that just the concept of having the airtight line externally with the breathable membrane, self-adhered or not, or obviously self-adhered is much more easy to achieve, can be complicated. Pam, sorry, go ahead.
Yeah, no, I was just going to add to that. I mean, Adam's explained it. What we're saying is it's not that you don't have a control layer. Vapor control layers are good. What it does mean is potentially downgrade that vapor control layer depending on the occupancy and the use. So it might be that actually a vapor check plasterboard is sufficient depending on the occupancy and the placement of the insulation. It might be that you can use a different vapor control layer in a different area. So for example, if you've got a swimming pool hall, you might use a high spec performance one like our Profoil 861. But in the areas that are storage, don't have a lot of moisture generation, are away from those sources, you might be able to downgrade that to a lesser vapour control layer and engineer that area to be more applicable. So it's very much about using the performance and the need of the vapour control layer and looking at how it can be used successfully, but not having to put as much focus on the ceiling, etc., and the sort of the really, really difficult jointing. And it doesn't matter too much if somebody's moved a plug socket there, because actually on a whole, the building's is safe.
And for a lot of people watching this will know the kind of services we offer and come to these conclusions. Can you explain, Pam, just for maybe clients or potential clients that don't know the independent tools we use to come to establish if we need a vapor control barrier, if the installation is in the right place, how we do that?
Absolutely. I mean, in a lot of cases, we can make quite a reasonable judgment based on experience by looking at a drawing. So you'll know straight off whether that particular project would benefit from a vapor control layer. That can then be checked by the sort of standard glazier method, which is a static state in things like framed buildings, timber frames, CLTs, etc. They're generally safe enough to be modelled within glazier methods, and there is guidance in BS 5250 as to what wall types benefit from what modelling method. So that gives us an idea of what that wall is going to be, and that will say straight off whether there's going to be interstitial or whether it's going to form on the back of the brickwork, which is in the cavity, isn't going to be a problem. Is it low, is it high, does it dry off, etc. So that gives us quite a lot of information. That software is actually on our website in our members area that people can sign up and work on their designs and do a little bit of pre-work, and they can send it to us for checking, etc. We can then also go into looking at more detailed analysis if there's any concerns about the project by using WUFI. So that's a dynamic simulation. So that actually takes into account moisture movement with heat and time of year, etc. You can basically hone it down to like hours of the day, and you can run it for a very long period of time. So there you're looking at how does that wall reach equilibrium? Does it go down, reach equilibrium after 2 or 3 years? Or are you actually getting an increase, which could be a problem? So there's quite a few tools that we can look at and analyse and troubleshoot and hone down what's right or not for your project.
Okay, great. Tony, I'll come back. I'm not sure if yours is actually a question. I'm trying to work out. So I think you're saying in relation to overall efficiency and certification, which method, concrete or CLT, is more passive centric? Maybe you can just clarify your question, or maybe I'm picking it up wrongly if someone else could try and answer that.
The best, St. Sidwell's Point used a mix of concrete, CLT, SFS, blockwork. So they had it all within their project design. I think, if I understand the question correctly, I think you've got more kind of thermal mass with concrete compared to, say, CLT. But you've got a lot of advantages when it comes to CLT with air tightness, but potentially even ease of install, with it coming like a jigsaw of loads of panels coming together. So it helps kind of create that system together. But there are a lot of hybrid systems with concrete and CLT as well on passive house designs. So I believe that's answering the question, but I'm not too sure.
Okay. Abode Architects, and I've got a few coming from email which are great, so please bear with us. Are you introducing more moisture to the building than you should be by encouraging a product with such a low SD value as the layer against the sheathing board, so warm side of the insulation? So Pam or Matt, maybe you can take that one. Pam's come off mute, so.
You want to go, Matt? I don't mind.
I guess Pam, thank you.
So I think the concern here is possibly, are you actually getting moisture coming into the building from putting that on the outside of it? No, because timber frame buildings for years have had membranes directly against the sheathing board. Okay, I get it, that was on the cold side. What you're actually doing is, by using low SD, it essentially becomes vapor or moisture neutral, it doesn't actually impede vapor movement in the building. So it can't increase the amount of vapor that's there. That's going to come by the design, the occupancy, the ventilation strategy or lack of ventilation strategy, and possibly some external moisture sources. What it does mean is that in the UK, certainly, we generally live in a heating climate. So we spend more energy heating buildings, although you wouldn't think it sometimes this summer, but we generally spend more time heating buildings than we do cooling. So the vapor drive is from inside to out. So actually you're pushing vapor out of the building. So you shouldn't be introducing more vapor and more moisture into the building. If you do get moisture in during the construction phase, it's going to dry out an awful lot faster through an low SD wrap-tight type product than it will through using a vapor control layer. So actually you're allowing that building to dry out faster through permeable insulation. Again, it depends on what that insulation is, but we're mainly seeing mineral wools or low SD insulations as well. So they all work quite well together. But as with everything, if there's a specific building or concern you've got or build-up concern, pop us an email to technical and we'll help out the best that we can to answer that and set any concerns to rest.
Okay, perfect. I have some great questions in from Bob Eden via email. So I'll just ask a couple, and again, Pam, on you, so I'll maybe get you to take these ones. Are you carrying out any post-completion surveys to validate your predicted outcomes? And have we had to make any adjustments to our future modelling predictions?
I think we're constantly, as you were sort of saying, we're constantly sort of getting feedback from sites that we've been involved in because we're not doing the actual full designs of the entire building. We rely on getting feedback from projects that we've been involved in. And as we've talked about, we've had some really, really encouraging results from testing. By using the airtightness line externally, you can even go in and do early testing on your airtightness to give you an idea of how your building is. Really, everything at the moment has been very, very positive towards the benefits of using a fully self-adhered membrane externally. I think there's always going to be looking at adjustments to modelling predictions, be that changes in climate, durations, adding. There's always going to have to be that. You have to sort of change with it, but it's been a learning curve over the last few years, but not anything that we didn't sort of expect, I don't think. So yeah, it's interesting, but
Yeah,
it is very much you do have to. I mean, yeah, it's
I can add to that if you want.
yeah, you go for it.
Longevity is actually a really key point when we're talking about vapor permeability, vapor tightness, air tightness, and the building physics, really. Membranes are still a relatively new kind of concept into modern construction. It kind of started off with sort of like papers on the outside of a building and plastics internally, but the actual technologies behind them have developed rapidly, more so than any other product in the construction design. One of the major benefits of Raptite is it's actually got been around for over 15 years now in climates all over the world on a vast range of projects. And we do keep in contact with a lot of those projects and have update data from that. So a lot of the kind of systems out there are very modern in comparison to Raptite, and they don't have a lot of that experience that we're lucky to have on some of those projects. And that's something we're constantly building, and you can keep track of it on our website with our case studies and by speaking to us as well. But yeah, I think it is
Because
quite an important point.
one of his other questions, to be fair, is there any indication of the vapor permeability becoming compromised over extended periods of time, i.e. do those tiny holes get blocked up at all? So I think you kind of covered that with obviously the long-term experience we have with Raptite, and I mean membranes in general. The main uniqueness of Raptite is just that it's self-adhered. Of course, we've been in membranes for 30 years. But with membranes, it's worth mentioning that, there's an awful lot of long-term aging that's done. So, your breathability is done when it's manufactured, and then this is all taken off and in laboratory settings looked at long-term conditions and aged. So all membranes, generally breathable membranes, will go through that, Wrap-Tite included. So it would give confidence, obviously, that the vapor permeability in however many years, etc., would still be functional.
It's possibly worth commenting on. I know it wasn't related to Wrap-Tite per se, but way back early 2000s when vapor permeable membranes were starting to make real inroads into roofing applications, there was concerns about the compromising, does the fibres, do the holes get blocked up? Now, in some cases, like the film that we use in Wrap-Tite, it's diffusion, so it's not actually air, so you're still going to get vapor to diffuse through that. But BBA did assessments and reviews where I think in essence they almost caked the top of membranes with mud and dirt and assessed it, and they were still permeable. So that's not getting it, because generally dust and dirt and all that is generally
porous, if you like,
natural and it's porous itself. It would only be a problem if you were starting like painting, plastics or bitumen or something over the top. That would be the point where you would get the clogging, not with sort of natural dust and dirt. Yeah. Mm-hmm.
The last question he asked was, how much impact does end user behavior, affect the actual outcomes? I wouldn't imagine that's a big issue. Anyone want to take that?
I suppose I kind of answered that. Again, with positioning Wrap-Tite externally, it's away from that end user kind of element of the design. I think you just need to reconsider if it's a small scale house and extension or any major works that's going to affect that through wall construction. Pam, anything to add there?
Yeah, and I was going to say, along with the modelling concepts that I talked about, we can artificially up a lot of the internal conditions. So we can actually look at it in the worst case, So if you had somebody, for example, a house that was only 2 people lived in it, all of a sudden, they had a family. Again, you have to rely on that whole building design, making sure that MEV, any extract fans, etc., are all working correctly, and that's all designed. But changing out membranes and using different membranes shouldn't make a huge impact on that. It is very much about treating it at its source and making sure that you have maintenance programs in place.
Both architects have come back, and because you answered the first question, I can stick with you. I've not forgotten about you, Matt, sorry. But just to follow on, so what they're saying is, so from their initial question, would that then encourage additional wetting of that insulation because the low SD is moving moisture too quickly to the insulation? And they said, I asked the above as the purpose of a VCL is to control moisture movement, whereas on the detail of insulation on the cold side of Wrap-Tite, we lose that control of movement as the SD is too low.
Yeah, so as we sort of the theme going through, we're not saying don't use a vapor control layer. We're just saying you don't have to have the reliance on a vapor control layer for the airtightness that you would have. And again, as I've just sort of pointed out with Bob's one, it's making sure that you actually have the right moisture control within the building so that you're not overloading the wall with moisture and vapor going into it. If you don't have the right controls and the right ventilation strategies, the right MVHR systems in a building, you're going to get problems regardless. And yes, that's where then excess moisture will dry out into the building and could cause problems in the winter. But really you are looking at, a properly designed, balanced building with a correct ventilation strategy for the type of building. The fact that you're using a vapor check or a vapor permeable membrane in the right place or in the middle of it, it shouldn't be causing any long-term issues. It should be, it's again about the balance of it all, not taking one item and expecting it to do too much or too little or whatever.
I mean, that's right. You won't find anything advocating in our literature website or technical salespeople saying Raptite is a replacement for a vapor barrier in this build-up. We can look at it, and it has been engineered out in projects, I know that, or as you said, Pam, downgraded. But essentially, the fundamental is we're moving the external airtight line to the external face of the building. And it also allows vapor to diffuse through, doing that function as the breathable membrane. So, but we would advise you to look carefully at the build-up, and we can help with that if we need to. Okay, so Charles Harrison, again, I've got a couple more by email, but what products do you have to help high-rise buildings progress internal and fitting out works on lower floors while the upper floor structures are being constructed to shorten the build program? Do we have anything for that?
Matthew, do you have anything? I do.
No, please go for it,
Okay.
Adam. Yeah.
But I think we worked on a project with a company called Formation Design in London over the last 2 years, which is a passive house scale project. And when you're working on passive house, with the air tightness, it is obviously key. But when you test the air tightness is quite important. If you're relying on your air tightness as an internal line, that testing's coming very late on into the design once you've kind of built your building essentially. The benefit of Raptite is you can start doing early air tightness testing internally as the Raptite goes on. So as you go up floor by floor, you can seal off rooms and or apartments and start airtight testing those apartments with the Raptite on the outside before you've even done your internal fit outs. So you can get an understanding what the air tightness performance is like of that apartment while the construction is still progressing on the outside. If you're getting a good result on that apartment, you can then begin to do the internal works, plasterboard, etc., as the building's still being constructed on the outside. So yeah, with Raptite, you can certainly do that, and it helps because you're getting your air tightness line on early in your building phase.
In the test in there, good.
Yeah.
Matt, what are the unique design and performance challenges when applying passive house principles to tall buildings with high facades? Alan has asked.
Good question. So yeah, so obviously the bigger the building, the taller the building, obviously there's going to be more air tightness. It's going to need to be certainly well wrapped. There's going to be a lot more details. Also, I'll have more thermal bridging. Obviously, you need to consider wind load management as well. With buildings being very close to other buildings, or whether that they're exposed. So there is some meticulous detailing that needs to be looked at, and obviously the coordination needs to be done very early at design stage. And obviously working with the likes of us and our technical team, who I think are fantastic, by the way, will certainly support and can help that. I noticed obviously with bigger buildings as well, the ventilation strategies become more critical because obviously you've got more of a building depending on the size of the dwellings inside. So you need to, and obviously we covered, Pam and Adam covered it. Obviously there's the bigger the build, the more I suppose the more care that needs looking into it. It's just you need to get the airflow right because ultimately you don't want to be causing moisture problems within the building.
So ventilation strategies become really important, don't they?
100%.
And there's just more complexities to consider.
They do, yeah.
Okay, great. Right, I've got another really good one by email, and then we'll come on to our last few questions because I know people it's Friday and we're going on a little bit. So let me find it. So Murgia. What are her recommended details on large-scale construction products at window and external door details to interface with SFS sheathing boards that include a Raptite membrane? So sequencing is often an issue where doors may not be installed until after masonry is complete at the sheathing board and Raptite. So Adam, you've had a lot to do with SFS. Do you want to take that question?
Yeah, I think actually it's one of the benefits of Raptite because we have a lot of flexibility around these areas. If you look in our install guides, we kind of have 2 details, but we can also adapt those accordingly to the project. So you can take your membrane into the reveal or into the door opening, the Raptite membrane into the reveal door opening, and then later on the windows or doors can be installed or if the window and doors are going to be installed first, we can then do a detail with your interface sealing system around that opening as well, whether we go over the top or seal the two products together. That gives a lot of flexibility to your project. I've even had projects before where the windows were being installed first and then the membrane was being installed as the building went up. But then there was some supply issues with the windows, and then they had to change that sequencing to not prevent the membrane being installed over the sheathing board. So later on in the project, we were doing the membrane into the reveals, and vice versa. So yeah, you get a lot of flexibility with the Wrap-Tite. I know it can be frustrating because we don't have one definitive answer, but it gives you flexibility to your design. And we also like to work with the sealing systems and the window installers and go off their recommendations and what their system best approach is. If they want to go back to the sheathing board, we would probably stick with their recommendation and detail accordingly with that. So communication is quite important for those details as well.
Quick follow-up question from a board on the specific topic that Adam's answering. Do you have a preference for window tape going on first or Wrap-Tite first? So do we have a position as to what we would recommend?
We don't have a preference at all, no. Again, we'll probably go with the preference of the window tape sealing system and their recommendation. If they want to go to the board with their system, we would abide by that. If they're comfortable going over the Wrap-Tite, we'll go into the reveal. Yeah, and
there are some benefits to going into the reveal because you have those sealed from further water ingress. Again, depending on the sequencing, and then you can actually link that in with any internal vapor control strategy. So there is a benefit there, but as Adam's touched on, it can be very much decided by the window and door manufacturer. Because it can be achieved in other ways. It just might be slightly easier and more robust to take the Wrap-Tite in first, but horses for courses.
Charles, I'll answer your question. So the webinar will be available on our webinar page. So if you go to proctorgroup.com/webinar, you'll find all of our webinars there, and this one will be added and it'll also be on the YouTube channel. And if you've registered by email, you will get follow-up and a link to the actual webinar, and you can then circulate that as far as you like. Okay, and let me have a look here. Two final questions from Jess, which are about passive house in different countries. So again, Adam, I'll probably have to come to you because you're our global guy. So if you can just answer them in one, that would be helpful. So how do passive house buildings perform in different climates, especially in extreme cold or heat? And can you share examples of any successful large-scale passive house projects around the world?
Yeah, I mean, there's loads now. It's becoming so much more popular. It used to just be kind of German, and now it's ventured outwards. A project I visited last year in New York was a student accommodation near a bridge, but it was the first high-rise passive house job in New York. I've forgotten the name of it now, but that's it's a landmark project rather than anything to amazingly look at. But one of the great projects that's passive house, one of my favourite ones is in the Middle East in Dubai, which I think was the first one in the Middle East, and that's the Space Center. Again, just for the fact that it's in a different climate with the reverse vapor drive going from the outside to in, so the design had to be slightly adopted, I think, to cater for that climate. I think that's the great thing with passive house. Although you've got the full passive house standard, there are variations within different climates, and you can accept that because you've got to make the building work from building physics aspect, and sometimes commercially as well. We've seen people adopt the standard to make it fitting commercially within their countries as well. So yeah, there is a lot of adoptions, but definitely worth checking out that Space Center in Dubai. I think it's a good project.
It's so interesting, I think, with passive house, how you can apply the same principles to, as you say, a space center in Dubai. There was a massive library project in New York as well that was really interesting in your accommodation one.
Just from the House of Cornell Tech, it was called.
House of Cornell Tech.
Yeah, that's the first high-rise passive house job, I believe, in the world. So yeah, worth checking out.
Lovely. Okay, I don't think I've missed any questions. If I have, I'm really sorry. We will answer them by email. You guys watching, you can obviously reach out to the team anytime you like. But a bigger technical team than just Pam and more people out and about than just Matthew and Adam. So yeah, we can really help support if needed. So just very quickly, a date for the diary, 31st of October. If you haven't heard about aerogel or space therm, so aerogel insulations or aerogel technology, it's really interesting. And we're actually using this in a lot of passive house projects, if that's your particular interest, in terms, especially for cold bridging and the retrofit side of things. It's a really interesting, very thin solution with extremely high thermal conductivity and other benefits. So if you can join us, 31st of October at 10 a.m., we'll be talking all about it then. So as I said earlier, if you go to our webinar page, you can get your personalized CPD certification. There will be a link to the webinar there, and you should get a follow-up. When you get your follow-up email, there'll be a short survey. If you fill it out, it just helps us. Even if you have any negative feedback, please share it. We'll take it constructively most of the time, and we'll try and make sure we can improve things. So if you give us a thumbs up if you've enjoyed today, please do so. And if you subscribe to our channel, you'll get more updates about what is coming. So I want to say thank you very much for attending, and thank you very much to Pam, Adam and Matt. Always great to have you guys answering the questions, and it's not often easy because you're on the spot with these questions coming in, but you've done well, so I appreciate it. And thank you to the viewers. If we didn't have people watching, then we wouldn't do these, so it's much appreciated. And I love today's session. I thought there were some brilliant questions, so it's really good to challenge us, and really enjoyed it. So wishing you all a lovely weekend, and we will hopefully see you on the 31st of October. Thanks, guys.
Thank you.
Thanks a lot.